Good morning, teachers and friends. Today, I will be having a presentation on different number systems. It is brought to you by the students of NUSI, Abiza, Raphael, Marcus, and Aryan. I shall start with the decimal system, a system which we are all familiar with. It is a system we usually use, and it ranges from the number of 0 to 9. Next is binary, which is usually used in programming, and most of you probably know it as well. It uses the numbers 0 to 1. Now let's move on to the less familiar octal. It uses the 0 to 7, which means it's base 8. We will be concentrating on this number system for this talk today. And just for information, there's also a system called hexadecimal, which is base 16. It uses the numbers 0 to 9 and the capital letters A to F to represent the digits 10 to 15. What are we going to learn today? We are going to learn the conversion of decimal to octal, octal to decimal, binary to octal, and octal to binary. Decimal with octal. Let's start with that. Keep in mind throughout this question that base 8 means that 8 in decimal is written as 10 in octal. This is because the place value of each digit in octal is represented by a power of 8. Let's have a question, for example, convert 125 decimal to base 8. So the first step is always to take the highest possible power of 8 and have the number you're using and divide it by that. So get your quotient and using the remainder, go for the next step. And for the next step, use the next power of 8 and continue doing this until you get 8 to the power of 0. Then just take all your quotients and that's your answer. 175 base 8. So let's take a look at another example. Using what I've just showed you, can you understand this working? Yes, that's right. You take the highest possible power, which in this case is 8 cubed, divide it, get the quotient, and repeat it until you get 8 to the power of 0. And then you just have to take the quotient, and that's your answer. It's as simple as that. Let's move on to octal to decimal, which is quite similar to the previous algorithm. This time, since you're doing the opposite, you have to take the last digit and multiply it by 8 to the power of 0. Use the next digit, multiply it by 8 to the power of 1, and so on. And then in the end, just add up all your numbers, and boom, you get your final answer. It's as simple as that. Let's move on to a slightly more complicated octal to binary. To convert octal to binary, replace each octal digit by its binary representation. For example, convert 51 to binary. So first take the 5 octal and it is written as 101 in binary. Then use 1 octal as written as 001 in binary. Therefore, just put both of them together and you get as 51 octal is 101001 binary. It's as simple as that. Now you may ask, why are we using 3-digit representations? This is because the maximum you can go with binary is 0 to 7. And for binary, the max you can get with 3 digits is also 7. So this is like the ideal situation. Let's move on to the opposite algorithm, which is binary to octal. It is basically the same thing. It's just that you divide each group into 3 and take each part and convert it into binary. I mean into octal. And then that's your answer. So as you can see, this is pretty similar to the previous algorithm, as it's just like the opposite of it. Now, addition in base 8 in octal. Okay. This is quite similar to base 10 addition. It's just that this time you carry over only when the sum is 8 or more, not when it's 10 or more. So because remember we're doing this in base 8. So 3 plus 5 is 8, so 0, and then we carry over 1 year. 1 plus 5 plus 2 is 8, so it's 0, and you carry over 1 year. 4, and then 4. Yeah, that the other is pretty obvious. So yeah, so you get 4, 4, 4, 0, 0. It's pretty similar to the decimal. And that the same goes for subtraction. You 3 minus 5, 6. Okay, yeah. Remember that each value is worth 8. So even if you like borrow, you have to make sure that the value of borrow is 8. So cancel this. This becomes 4. But you don't plus 10 here, instead you plus 8, so this becomes 11. And as you all know, 11 minus 5 equals to 6, and you continue the same process, and you should end up with the answer 2126. It's as simple as that. Now many of you may be wondering, why learn this? What is the use of this? Well, you'll be surprised to know that octal is widely used in computing, right? um, um, is in 12-bit, 24-bit, and 36-bit words. This is because they are ideal abbreviation of binary, as binary is very tedious. So this machine, because of their word size, because octal is divisible by 3, like each octal digit represents 3 binary digits, like I showed you earlier. So 4, 8, or 12 digits continuously display an entire machine word. So this is more effective than the binary system, and I am very sure that even your video games might contain this octal programming. So in all, octal is a very useful tool, and it's not only just for the sake of learning it. In fact, none of your hardware devices could work efficiently without this octal programming. And that brings me to the end of my presentation of octal. Thank you.